Iron Man. He wears a super-powered iron suit that is a masterpiece of futuristic engineering and fictional technology. Using the laws of physics, we're asking the question, how accurate was Tony Stark's Iron Man suit? We are suspending the fact that he is a fictional superhero and making an assessment based on real-world physics. We start with the Arc Reactor. One of the biggest challenges of the Iron Man suit is energy, having enough to power all of its functions. In the MCU, Tony Stark creates a miniature arc reactor that provides virtually limitless energy to power the complex functions of the suit. But the reactor has two major real-world problems that break the laws of thermodynamics. The energy density required for such a device far exceeds what is remotely achievable with any known technology today or in the future. Tony Stark refers to nuclear fusion as the method used to generate the immense amount of power needed. But fusion requires large facilities to generate even a tiny amount of energy. Just look at our sun. It's not something that's going to fit inside a chest piece. An even bigger problem is the need for the arc reactor to be incredibly efficient to avoid overheating. A device generating that much energy would create ungodly amounts of waste heat, and dissipating that heat would be a massive problem in a confined space. The laws of thermodynamics state that as the amount of energy added to a system increases, the heat generated within that system also increases. With that kind of enormous energy creation, the amount of heat it would generate would eviscerate Tony Stark in a second. Next, the problem with flight. The Iron Man suit is equipped with Repulsor technology that allows Tony Stark to achieve his controlled flight. Earlier Iron Man suits would weigh several hundred pounds, especially considering the armor plating, weaponry, and other mechanical components. To achieve flight, the repulsors would need to generate an enormous amount of thrust to overcome the suit's significant weight. In the movies, the repulsors seem to operate on some form of directed energy propulsion, which doesn't align with any current understanding of physics. For propulsion to work, there needs to be an expulsion of mass, like in jet engines or rockets, which use combustion gases for thrust. The repulsors seem to work without any visible mass being ejected, raising questions about what type of energy or force Tony is using. Even if the suit could achieve flight, the kind of acceleration Tony Stark undergoes during quick maneuvers would result in extreme G-forces. The human body can withstand about 9 Gs, or 9 times the force of gravity for short periods, before losing consciousness. The Iron Man suit, with its rapid changes in direction and speed, would subject Tony Stark to G-forces well beyond what a human body could handle, resulting in severe injury or death. The next problem, armor durability. The Iron Man suit has near godlike durability, able to withstand bullets, explosions, and massive impacts from superhuman and supernatural forces. Nothing even close to vibranium exists that could offer the level of protection the Iron Man suit provides, while still being lightweight and flexible enough for Tony Stark to move. There's also the problem of weight versus mobility. For the Iron Man suit to be as strong as depicted, it would have to be incredibly thick, which would add a massive amount of weight. Tony Stark moves with complete ease, performing acrobatic maneuvers that are impossible for someone encased in heavy armor. Even the best real-life ballistic armor, such as that worn by soldiers, offers protection against bullets, but is very heavy and limits mobility. There is also the problem of kinetic impacts. In many scenes, Iron Man takes massive blows from large objects and opponents such as Thor's hammer, the Hulk, or falling from extreme heights. Even if the armor could absorb most of the force in these massive blows, the sudden deceleration or acceleration would result in internal injuries that would kill Tony Stark instantly. There are also major real-world problems with the weaponry and ammunition. The Iron Man suit is equipped with a variety of weapons, from repulsor blasts, missiles, and even lasers. While futuristic technology allows Stark to carry such an arsenal, the physics behind storing and deploying these weapons pose significant problems. There are major issues with the miniaturization of weapon systems. Storing enough ammunition or missiles in a suit the size of the Iron Man armor would be impossible. Each weapon requires physical space for its components, as well as a source of energy or propellant. Even if we assume that the Arc Reactor can power some energy-based weapons like lasers, the physical limitations of space make it hard to explain how such a vast array of weaponry is packed into the suit. These installed missile and weapon systems would also make the Iron Man suit very volatile. With every kinetic impact, there would be a significant chance of destroying or even exploding any one of these weapon systems. There is also a major problem of heat and recoil when firing the Iron Man suit's high-energy weapons, which would need to be managed by the suit's systems. Without adequate cooling mechanisms or recoil compensators, the Iron Man suit would likely overheat or become destabilized after firing its weapons. Next, life support and sustenance problems. In the MCU, the Iron Man suit provides life support for Tony Stark in various environments, including outer space, underwater, and in high-altitude scenarios. The Iron Man suit would need to have a pressurized air supply and recycling system for carbon dioxide, released by Tony Stark's breathing. These are not visible anywhere, and if they were, they would be incredibly bulky. If they are contained in the suit, they are miniaturized to the point of being impossible. The fragile nature of these systems would make them hard to protect and keep safe in a fight. You have to consider the energy consumption to maintain life support systems as well. Given the suit's other demands for propulsion and weaponry, it's questionable whether enough energy could be supplied without depleting the Arc Reactor. If we assume that the Arc Reactor can easily power everything the suit needs it to, it would all fall back to the biggest problem the Iron Man suit has: the law of thermodynamics. The only thing that supervillains would need to do is to wait for Tony Stark to use the systems on his suit. The amount of energy used would most likely melt the suit, and Tony Stark with it. From energy generation to flight dynamics, the Iron Man suit defies these laws, but in doing so, it creates an exciting and simply awesome superhero. This is Dimension Zero.